Hey everyone, today we're going to be taking a look at section 1.4, which is solving absolute value equations. Now in this one, we're just going to kind of get to the quick and dirty of it. Exactly how do we solve these absolute value equations? So you should remember from Algebra 1 that the absolute value of anything is just the positive version of whatever you have there. For example, over here we've got the absolute value of -2. Well, that's just equal to 2. Whatever's inside the absolute value, what is the positive of that? Also, we can see that if we did the absolute value of 5, well, we would just get 5 because it is, the positive of 5. Well, 5 is already positive, so the absolute value of 5 is in fact 5, which leads us to realizing that the absolute value of anything has got to be greater than equal to 0. In other words, it cannot be negative. Now, if I take this example that we have here, consider the absolute value equation, absolute value of x plus 2 is equal to 3. So we're supposed to describe values of x plus 2 that make the equation true. Now, one possibility that we have is that x plus 2 is actually equal to 3. But the other equally valid solution here would be if whatever is inside the absolute value is equal to -3. So x plus 2 could be also equal to -3, because as we know, the absolute value of 3 is 3, and the absolute value of -3 is 3. Now, solving these two equations is not a problem. We'll do that really quickly. With that first equation, we'll subtract 2 from both sides, which gives us a 0 pair, which I've outlined here in green, which is equivalent to x equals 1. We'll do something similar to the equation on the right here. Subtract 2 from both sides, which gives us the equivalent equation x equals -5. So that did it. We described the values, and then we used the description to write two linear equations. Here's linear equation 1, x plus 2 equals 3. Linear equation 2, x plus 2 equals -3. And then we've solved them. So what were the two linear equations? They were x plus 2 equals 3 and x plus 2 equals -3. Part C, how can you use linear equations to solve absolute values? And that's kind of a difficult question, I think, to answer. You just kind of create the two linear equations and then you solve them, and that gives you your two solutions. So we're going to skip from here right to, actually, let's write that down. Write the linear equations that represent the absolute value equation, and then solve each equation. So there's a little bit more here. This is kind of graphical. We'd probably do this in class, but I think we're going to skip this for the video, I think. Well, maybe we'll do this right here. On the number line, locate the point for which x plus 2 equals 0. Well, that's pretty easy. I think the point where x plus 2 equals 0, that would be what x equals -2. So we'll put a point right here. Okay. And then locate the points 3 units to the left and to the right. So let's count. To the right, we have 1, 2, 3 units. That would be at x equals 1. And then to the left, we have 1, 2, 3 units to the left. That's x equals 5. We'll put points there. Okay, what do you notice about these points? Well, these are the same solutions that we got over here, -5 and 1. These are the same. So if you want to use a number line, and this is really high-ordered mathematical thinking here, you do a couple things. First, you would make the absolute value equal 0. And then you would locate all points 3 units away from the point that we located in number 1. Now it says for example over here because here we had a 3, which is why we're using a 3 here. If this was a 5, then obviously this would say locate all points 5 units away from the point that we found in part 1. Okay, and exploration 3 we're definitely going to skip, and we're ready actually for the rest of these note-taking things. Absolute value equation, that's any equation that contains an absolute value. Now, extraneous solution, that's a little bit more difficult to define. That's going to be a solution that's true algebraically, but it's not true realistically. So if we were talking about a perimeter, sometimes you'll get something that says, the perimeter is equal to a negative number. Well, we all know that because it's distance, this is kind of nonsense. A perimeter can't be equal to a negative number. So that's why we would call that an extraneous solution. So here are 4 properties of absolute values. We'll go over them over here and we'll write down what they mean. The first one, absolute value of A is greater than equal to 0. There are 2 ways to think about property number 1. And the first one is that the absolute value is never negative. And the other way to think about property number 1 is that the absolute value is either going to be 0 or positive. Number 2, we have the absolute value of negative A is equal to the absolute value of A. And what this is trying to say, this is saying that the absolute value of a number is the same as the absolute value of that number's opposite, or that number's negative. Numbers 3 and 4 are very algebraic, and number 3 just says that if you have the absolute value of the product, then that's the same thing as the product of the absolute values. So we can either take the absolute value before we multiply or after we multiply, it doesn't matter. And number 4, the absolute value of a quotient, of a division, is the same thing as the absolute value of the dividend divided by the absolute value of the divisor. Again, with multiplication and division, you can take the absolute value either before or after you do the operation. So multiply the absolute values or multiply the numbers and then take the absolute value. It's the same thing. And that brings us actually to, this is going to be our problem solving strategies. So problem solving strategy number 1. Now this is a linear equation. The absolute value of a linear equation equals a constant. So in this case, you make the absolute value, you make the inside of the absolute value equal to the constant, or you make the inside the absolute value equal to the negative of the constant. So let's take a look at an example to see how that works. So the example that we're going to use is we're going to say that the absolute value of 2x minus 9 is equal to 1/2, or 0.5. So this is our example. Let's make that black, just so that you can see that that's where we started from. To find the solution, we're going to say that 2x minus 9 is either equal to 0.5, or 2x minus 9 could be equal to negative 0.5. And once you've set up these 2 equations, you can just go ahead and do everything that we did from sections 1.1 to 1.3. So we'll do those really quickly here. Add 9 to both sides. And then we'll divide by the coefficient. This gives us x equals 4.75. We'll do the same thing to the other side. We'll start by adding 9 to both sides. And then we'll divide by 2. And that gets us to x equals 4.25. Now, sometimes you're going to see that the solution here can be written as what we would like to call, in the math people, we would call that the solution set. And in the solution set, we put the answer in braces, and braces are the name of these curly looking parentheses. And any number here inside here would be part of the solution. So that's the same thing as saying x is equal to 4.25 and x equals 4.75. Just put the 2 numbers in braces, and that's the solution. A little more of an economical way of writing the solution. Okay, so that's the easier of the problems. And the other difficult problem would be, what if we had two linear solutions that are two linear equations that are equal to each other? Well, then we'd do something similar. We would make the first one equal to the second one. And then we'd also make the first one equal to the opposite of the second one. So let's see how that works in practice. So for this one, we'll have the absolute value of x plus 1 equals the absolute value of 2x plus 5. You're going to notice that the left side, this right over here, that's a linear equation. Linear plus constant. And then on the right side, that's another linear equation, linear term 2x plus constant 5. Okay, so to solve this, we're going to write down two equations, either of which will give us a solution. The easier one to write would be just to pretend that there were no absolute values at all. So we're going to write this with no absolute values. Negative x plus 1 equals 2x plus 5. And then we're going to solve that. But the other one that we're going to solve, we're going to make that first absolute value, negative x plus 1, we're going to equal it to the negative of 2x plus 5. So it's important that you observe the rules here. We're going to put a negative sign in front, and then we're going to put a parenthesis around the entire inside. So basically we're trading the absolute values for parentheses and putting a negative in front of it. Okay, so this is a place where people commonly make mistakes. All right, let's solve this first one. We're going to notice in both of these that we have a linear term on the left side and the right side. You can see them both over here. The smaller of those two linear terms is negative x. So we're going to start off by adding x to both sides in the left case. That's going to get me 1 is equal to 3x plus 5. Then I'm going to subtract 5 from both sides. That gets us to negative 4 equals 3x. Now the coefficient here is that negative is at 3. So we're going to divide both sides by 3 now. And that gets us to our first solution, where x equals negative 4/3. Let's move on. Let's do the second equation here. First of all, I'm going to distribute that negative sign. You see it over here. This negative sign needs to go to the first term and to the second term. And when you distribute a negative sign, all you're really doing is making all the terms inside the parenthesis into their opposites. So the opposite of 2x is negative 2x, and the opposite of plus 5 is minus 5. Now taking a look at this one, which is smaller, negative x or negative 2x? Well, actually, the smaller of the two is negative 2x. So I'm going to take this opportunity to add 2x to both sides of the equal sign. That gets us to an x plus 1 equals negative 5. We'll subtract 1 from both sides. And that gets us to the solution x equals negative 6. Now, if you wanted to write these in set notation, you would write yourself the set of the numbers negative 4/3 and negative 6. Okay. So that is it for our notes. We'll see you on the next video when we do these extra practice videos.